Rule is what you use when you don't have the situation that you have for sine rule. So that means that if you have a side, they give you all three sides, and you're looking for an angle, you can use cosine rule. Or if you have side, angle, side, give you two sides and include an angle, you use cosine rule. The one thing to remember about this is whatever side you're looking for, okay, the angle opposite of that is usually given to you, or vice versa, okay? Whatever angle you're looking for, these are the formulas you use if you're looking for the angle. You're always subtracting the side opposite of that angle you're trying to find. And these are your set formulas, okay? And they do change based off of whatever the variables are, okay? But again, whatever side you're looking for, you usually know the angle opposite of that side you're looking for and vice versa, okay? So what we're going to do is we're going to take a look at a few examples. Then we're going to talk about area of a triangle and then go from there, okay? So find A and the missing angles. So we have this not this right triangle, we have this triangle here. Remember, sine and cosine rules are used when you don't have a right triangle. So we want to find A first. And so we would set it up using the formula A squared equals 8.9 squared
plus 13.2 squared
plus 13.2 squared
minus 8.9 times 13.2. And then cosine 80.
There you go. This is the formula that you would use to set up. Now, as much as you guys do not like doing this, I strongly suggest again you make sure that you show this step. Because if anything goes wrong in your calculations, for whatever reason, you can at least get a method point and an accuracy point because you knew what formula to use and you plugged it in correctly. It's just either you rushed through it, you missed the square, you were in radian mode, you should have been in degree, or you might, who knows, okay? So you'll get that number, and then your last step would be to do what to it?
Square root it.
You would take the square root of it. Even though, yes, we take the square root of something as plus or minus, we only want the positive version here. So whatever that long number is, when we take the square root of it, we get
14.6.
Can I get confirmation?
Yes.
So 14.6 centimeters. About. Alright? Then to find the missing angles, yes, we can use cosine as well, but if you feel more comfortable using sine, you can do that as well. Okay, so either or. You can use both of them in the same problem. Since I want to make sure that we get the practice on cosine, I want us here to use cosine rule to find one of the two angles. Which angle do you want to find? B. Okay, so to find B using cosine rule, we could use sine, but I want to put the emphasis on cosine rule. We want to find angle B. So using your formula, that means we're going to take which two sides first and add them together?
Little a
The
squared
lowercase a squared, that long decimal squared, plus 13.2 squared. Okay, so the two adjacent sides, and then we're going to subtract that last side. The side across from the angle we're trying to find is the side that gets subtracted. Does everybody see that? Then we're going to divide it by 2 times A times C. And whatever number you get, once you type all that into your calculator, before you take the cosine inverse, should be a number that is less than 1. You get a number that's bigger than 1, you messed up. Anybody figure out a number beforehand, or did you try to just type it all in your calculator one time?
I got it all in one time.
Okay. Well, you should have got a number that was about 0.799. So that way when you take the cosine inverse of it, you get what? Okay? So again, I understand some of you guys want to just go ahead, do the whole thing. But don't be talking about it's stupid when you lose points because you decided to skip out on those steps. The only person that would be stupid. Okay? Lastly, how do you find angle C?
You can add them together.
You can add them together. And then do what?
Subtract it from 180.
Subtract it from 180 because there are 180 degrees in the triangle. So the last angle is about what?
63.13.
And there's cosine. Okay? Just definitely want you guys to get practice using these rules since we use sine already. Okay? Questions? Anybody not get these numbers? Having issue typing into your calculator? Alright. Give you guys a moment to figure out those angles A, B, and C.
The top part of the fraction would be negative 14.23.
The top.
It was negative 12 point.
Okay.
I got negative 14.
You got negative 12.34.
I got negative 12 here.
Why doesn't say the answer to them? Oh, no.
You might have did it different. It's about 105 for angle A.
No, I'm talking about the
Good stuff. You guys get this for angle B?
Yes, ma'am.
Good stuff. So lastly, angle C would be questions on using cosine rule. Think it's the whole question. We did do this one. We used right triangles, right?
Yeah.
That one was very much a cosine rule one as well. You guys remember how the picture set up? You had this in your notes already, so you should have to write this again. Remember, it started from the dot and we traveled what?
North.
We traveled north for 30 kilometers before driving anchor, and then B set a bearing of 50 degrees. Remember, bearings come from clockwise from the north direction. So then it traveled this way for 65 kilometers, right? Before driving anchor, we had to find the distance between the two ships. Here, you very well could have used what? Which rule? Cosine, because this is the side that we're looking for, okay? Do this one real quick, using cosine rule. And see if we got the same thing we got last class. So, hopefully you guys set it up like so. I know some of you guys want to just go ahead and skip this part, but I'm trying to stress to you the importance of at least setting it up so you get your method point and your accuracy point for at least knowing the right formula and plugging in the right values. You should have had what? 30 squared plus 65 squared 2 times 30 times 65 times cosine 50. Please tell me that you're also not doing this. You're not trying to square these, add them together, then multiply this, and then subtract whatever this number is from this number, and then take the cosine 50. Please tell me you're not doing this. Okay, good stuff. So then you get what? What was the answer that you guys got after you found that and then took the square root?
51.
Point.
51.
51.2.
Nearest kilometer, 51.
It does say that, yep.
Thank you.
So then nearest kilometer will be 51 kilometers. And real quick, anybody got the notes out?
I did.
Do we get the same answer?
Yeah.
Here we go. Alright? So there you go, there's cosine rule. Questions on using cosine rule? Last bit, area of a triangle. This is for your non-right triangles. The formula is 1/2 BC sine A, realizing that that could change depending on what side you're given and what the variables are for your triangle. Okay? It could also be 1/2 AC sine B, or 1/2 BC sine, oh, I already said that one, AB sine C. Okay, so basically, you're given side angle side, it asks you to find the area, so basically you just multiply the two sides, the sine of the angle in between, and divide by 2. That's how you find your area of a triangle. And this can be applied to any triangle. It can be applied to right triangles as well, but this works for any and every triangle now. Instead of old school classic 1/2 based on side. So, hopefully set it up as 1/2, 8.4 times 7.8, sine of 82.7, which is what?
32.5 centimeters squared.
And do not forget, area is units squared. I probably think I got one more example up here that I'll do, and that I'll put onto the video before I post it. For this particular problem, it says the area of the triangle is 50 centimeters squared, you're looking for the theta. That right there means you are looking for the angle, so you use the fact that the area formula is 1/2 AB sine C. Or in this case, 1/2 EF sine D. And you plug in what you're given. Your area is 50. One of your sides is 13.7. The other side is 8.2. So then to find your angle, what you're going to do is you're going to take half of 13.7 and 8.2 to get 56.17, and that is that decimal. It's not rounded or anything like that. You're going to divide 50 by that number to get about 0.89 and some change. And then to find the angle that you're looking for, your theta, I'm going to go ahead and change that to a theta. You're going to take the inverse of sine, and you'll find that theta is 62.9 degrees. And you can always check that by plugging back in.